30 days, one aging laptop, one operating system that millions of people have heard about, but most have never seriously considered running on their primary machine. The question that drove this experiment was not abstract or theoretical. It was practical, specific, and relevant to a growing number of people who are watching their older hardware struggle under the weight of an operating system that was not designed with their machine's limitations in mind. Can Linux Mint, a distribution that has built its reputation on accessibility, stability, and performance efficiency, genuinely transform the experience of using a low-end laptop that Windows 11 has made feel sluggish, unresponsive, and increasingly frustrating? The answer required more than opinion. It required benchmarks, specific, reproducible measurements of boot time, memory consumption, processor utilization, storage performance, and application responsiveness. It required 30 days of actual use, web browsing, document work, media playback, software installation, and the ordinary friction of daily computing on a machine that represents the kind of hardware millions of people are still using and cannot immediately replace. The results were not entirely what was expected. Some findings confirmed what Linux advocates have argued for years. Others introduced complications that the enthusiast community does not always acknowledge with sufficient honesty. Everything follows. The laptop chosen for this experiment was not selected arbitrarily. It was chosen because it represents a category of hardware that is both extremely common and increasingly poorly served by the direction of modern Windows development. The machine is a mid-range laptop from approximately 8 years ago, the kind of device that was a reasonable purchase for a student or office worker at its time of manufacture, and that has remained in service through a combination of modest computing needs and the reluctance to spend money on replacement hardware that is difficult to justify when the existing machine still technically functions. The specifications: an Intel Core i5 processor from the 6th generation, running at a base clock of 2.3 GHz with boost capability to 2.8 GHz across 2 cores and 4 threads. 8 GB of DDR4 RAM running at 2133 MHz in a dual-channel configuration. A 256 GB SATA solid-state drive that replaced the original mechanical hard disk in a previous upgrade attempt, itself a performance improvement that extended the machine's useful life, but that has not been sufficient to make Windows 11 feel genuinely responsive. Intel HD graphics, 520 integrated graphics with no dedicated GPU, a 1920 by 1080 display at 15.5 inches. The machine, originally shipped with Windows 10, was upgraded to Windows 11, meeting the minimum hardware requirements through a TPM 2.0 module present on the motherboard, and had been running Windows 11 version 23H2 in the months before this experiment. The choice of this machine was deliberate for several reasons. The 6th generation Intel processor represents hardware that sits in a large installed base globally, old enough to show meaningful performance constraints under Windows 11's background service overhead, but recent enough to be supported by current Linux kernel driver coverage without significant hardware compatibility challenges. The SATA SSD eliminates the additional variable of mechanical storage performance from the comparison, allowing a cleaner measurement of operating system overhead on a fixed storage capability. The integrated Intel graphics represent the most common graphics configuration in the category of older laptops being considered. Before the Linux Mint installation, a clean installation of Windows 11 23H2 was performed, removing accumulated application installations and configuration changes that might have degraded Windows performance beyond the operating system's baseline behavior. This established a fair comparison baseline: freshly installed Windows 11 versus freshly installed Linux Mint on identical hardware, measured under equivalent conditions. Linux Mint version 21.3, based on Ubuntu 22.4. LTS, and using the Cinnamon desktop environment, was selected as the test distribution. Cinnamon was specifically chosen because it represents Linux Mint's flagship desktop environment, the one most prominently recommended for users transitioning from Windows, the one that most closely approximates a familiar desktop workflow, and the one against which Linux Mint's performance reputation is most commonly evaluated. Installation from a USB drive, prepared with the official ISO, proceeded without complications, requiring approximately 15 minutes from boot to configured desktop. First impressions of the installed system were immediately noteworthy. The desktop loaded quickly. The interface responded to input without the hesitation that had become characteristic of the Windows 11 experience on this hardware. And the default application suite, including the Firefox browser, the LibreOffice Productivity Suite, and the Timeshift backup utility, was immediately available without additional installation. The experiment's 30 days began from that initial boot. The benchmarking methodology was designed to measure both the categories of performance that translate directly into user experience and the lower-level metrics that explain why that experience feels the way it does. Boot time was the first measurement category. Cold boot, from power button press to a fully loaded interactive desktop with background services settled was measured 5 times on each operating system, with the results averaged to reduce the influence of individual measurement variance. Windows 11 averaged 52 seconds from power button to interactive desktop. This measurement includes the Windows boot animation, the login screen, and the approximately 20 additional seconds during which background services complete their initialization, and the desktop becomes fully responsive to input without stuttering. Linux Mint with Cinnamon averaged 23 seconds from power button to interactive desktop. Background service initialization was largely complete within that window, with the desktop feeling genuinely responsive at the point the measurement concluded. The difference, 29 seconds, is not merely a number. It represents a qualitatively different experience of starting the machine, one that eliminates the routine frustration of waiting for a laptop that should be ready to work to actually become ready to work. RAM usage at idle, measured after boot with no applications open and background services settled, showed an equally significant difference. Windows 11 consumed approximately 3.8 gigabytes of RAM at idle on this hardware, leaving approximately 4.2 gigabytes available for applications. Linux Mint with Cinnamon consumed approximately 1.1 gigabytes at idle, leaving approximately 6.9 gigabytes available. On a machine with 8 gigabytes of total RAM, this difference is operationally significant. Windows 11's idle memory consumption means that opening a browser with multiple tabs, a document editor, and a PDF viewer simultaneously pushes the system toward its memory ceiling, producing the swapping behavior that degrades performance perceptibly. Linux Mint's lower idle consumption provides meaningful headroom for the same application workload. CPU utilization at idle showed a similar pattern. Windows 11 maintained a background CPU utilization ranging from 8 to 15% across multiple measurements, driven by anti-malware service executable, Windows Update activity, telemetry services, and the Windows Search indexing service. Linux Mint's idle CPU utilization ranged from 1 to 4%, with occasional spikes associated with background update checking that were brief and infrequent. Application launch speed was measured for a representative set of common applications. Firefox launched in 3.1 seconds on Windows 11 and 1.8 seconds on Linux Mint from a cold start. LibreOffice Writer launched in 4.2 seconds on Windows 11, where it was installed for cross-platform comparison, and 2.6 seconds on Linux Mint. The file manager opened in 2.8 seconds on Windows 11 and 0.9 seconds on Linux Mint's Nemo file manager. These differences reflect the combined effect of lower background CPU competition and more available RAM cache on Linux Mint. Browser performance was measured using the Speedometer 2.1 benchmark, which tests JavaScript execution speed and DOM manipulation performance in a web browser. Firefox 1 and 21 produced a score of 47 on Windows 11 and 53 on Linux Mint, a difference of approximately 12% that reflects the lower background overhead competing for CPU resources on Linux Mint, rather than any fundamental difference in browser capability. Storage performance using the Crystal diskmark equivalent on Linux, specifically the FIO benchmarking tool, showed nearly identical sequential read and write performance between operating systems, as expected for SATA SSD storage that is not meaningfully affected by operating system overhead at the sequential transfer level. Random small file read performance showed a modest advantage for Linux Mint, approximately 8% higher in 4 kilobyte random read operations, which likely reflects lower competing background storage activity. Thermal behavior during sustained workload, specifically a 15-minute CPU-bound encoding task, showed that the laptop reached a peak temperature of 87 degrees Celsius under Windows 11 and 81 degrees Celsius under Linux Mint, with Linux Mint's lower baseline CPU utilization producing less heat generation during the workload's initialization phase, before both systems converged to similar thermal behavior under sustained load. Benchmark numbers establish a performance baseline. They do not tell the story of what it actually feels like to live with an operating system across a month of varied daily use. And the daily experience contained both the confirmations and the complications that define an honest assessment. Web browsing was the activity that benefited most immediately and most consistently from the transition. Firefox on Linux Mint, with the additional RAM headroom that the lower system overhead provided, handled 12 to 15 open tabs, with noticeably less sluggishness than the same browser on Windows 11. Pages loaded without the occasional pauses that had become normalized on Windows, pauses that, in retrospect, were likely attributable to the browser competing with background Windows services for memory and CPU time, rather than to any inherent limitation of the browser itself. Office work using LibreOffice was functional and, for most document tasks, fully adequate. LibreOffice Writer handled documents of moderate complexity without issues. LibreOffice Calc processed spreadsheets with typical formulas and moderate data volumes without complaint. The interface is not identical to Microsoft Office, and users who have spent years building muscle memory around Word and Excel's specific interface conventions will notice the difference. The compatibility story for document exchange, opening and saving files in Microsoft Office formats, was adequate for most purposes, but produced occasional formatting inconsistencies in documents with complex layouts that would be problematic in professional environments where precise document formatting is a requirement. Media playback required a brief additional step that the installation process does not fully automate: installing multimedia codec packages that are not included in the default Linux Mint installation due to licensing considerations. The Software Manager, Linux Mint's graphical application installer, presents this option prominently, and the installation is straightforward, but it represents a point of friction that Windows users who expect media playback to work immediately without additional steps will notice. Once the codec packages were installed, video playback of common formats including MP4, MKV, and AVI was smooth and performed without issues. Software availability was the area that required the most significant adjustment in workflow and expectations. The Linux Mint Software Manager provides access to a substantial library of applications, far more than most users will need for typical computing tasks. However, several applications that are deeply embedded in many users' workflows are not available for Linux, and the alternatives, while often functionally capable, require learning and adaptation. Adobe Creative Cloud applications, Photoshop, Illustrator, Premiere are not available natively on Linux. Microsoft Office is not available natively on Linux. Several Windows-specific utilities, gaming anti-cheat systems, and professional software packages have no Linux equivalent. The gaming situation deserves specific attention. Linux Mint supports gaming through Steam's Proton compatibility layer, which has matured significantly over the past several years and enables a substantial and growing library of Windows games to run on Linux with acceptable performance. However, the hardware in this test, a 6-year-old integrated graphics chip with 128 megabytes of dedicated video memory, is not a gaming-capable configuration regardless of operating system. Games that were tested on this hardware included simple 2D titles and older games with modest graphics requirements, which ran acceptably. Any expectation of gaming performance beyond what the hardware physically supports is unrealistic on either operating system. Battery life showed a meaningful improvement under Linux Mint. A standardized battery rundown test, screen at 50% brightness, Wi-Fi active, Firefox with 5 tabs open, light document work, produced 5 hours 40 minutes on Windows 11 and 6 hours 55 minutes on Linux Mint. The difference is attributable to lower background CPU utilization, reducing power consumption during periods of light user activity. Updates across the 30-day period were managed through the Linux Mint Update Manager, which presents available updates with clear information about their nature and importance, and allows the user to apply them selectively. The update experience was consistently less disruptive than Windows Update. No mandatory restarts at inconvenient times, no update sessions that consumed significant portions of working time, no situations where the machine was unavailable for use while an update completed. Driver support across the 30 days produced no significant hardware compatibility issues on this machine. Wi-Fi, Bluetooth audio, the integrated camera, USB ports, and the SD card reader all functioned correctly with the kernel drivers included in Linux Mint 21.3. This positive experience reflects the generally good Linux driver coverage for Intel hardware. Machines built around AMD or certain Broadcom Wi-Fi chips have historically been more challenging. The experiment produced several findings that departed from initial expectations in both directions, areas where Linux Mint exceeded what was anticipated, and areas where Windows retained advantages that were clearer than expected. The most positive surprise was the stability of the system across 30 days of use. Not a single system crash, kernel panic, or application-induced system instability occurred during the test period. Updates applied smoothly. The Timeshift Backup utility, which creates system snapshots that can be used to restore the operating system to a previous state, functioned as documented and provided a level of system recovery confidence that Windows System Restore, in the author's experience, does not consistently match. The Cinnamon Desktop's customization capability was a secondary positive surprise. The desktop environment allows adjustment of panel position, taskbar behavior, application menu layout, keyboard shortcuts, and visual themes with a granularity that Windows 11 does not provide through its official configuration tools. Users who find Windows 11's interface constraints frustrating, the inability to move the taskbar, the limited customization of the Start menu, will find Linux Mint's flexibility in this regard genuinely refreshing. Hardware support for the function keys, the special function layer on the laptop keyboard that controls screen brightness, volume, keyboard backlight, and media playback, worked correctly without additional configuration. This was not guaranteed on Linux hardware, and its reliable operation removed a category of friction that Linux detractors sometimes cite as a persistent pain point. The areas where Windows retained clear advantages were equally important to document honestly. The Microsoft ecosystem integration that many users have built their workflows around, OneDrive, Outlook, Microsoft Teams, the native Microsoft Office applications, is not replicated on Linux Mint with equivalent polish or integration depth. Web-based alternatives exist for most of these, and native Linux clients exist for some, but users who are deeply embedded in Microsoft's ecosystem will feel the absence of native application support as a genuine productivity impact rather than a minor inconvenience. Peripheral compatibility was an occasional challenge. A wireless printer that had worked seamlessly on Windows required significant troubleshooting on Linux Mint, identifying the correct driver package from the manufacturer's website, installing it through the terminal rather than through a graphical installer, and verifying the configuration through CUPS, Linux's printing system. The printer ultimately worked, but the process required a level of technical comfort that cannot be assumed for users without prior Linux experience. Software discovery, finding and evaluating Linux alternatives to Windows applications, required time and research that Windows users are not accustomed to investing. The software manager is competent, but it does not replicate the familiarity of knowing which Windows application to reach for in any given situation. Building equivalent familiarity with Linux alternatives is a learning investment that the 30-day period only partially completed. The honest answer to the question of who should consider switching to Linux Mint requires resisting the temptation to advocate for a simple yes or no across all situations. The evidence from 30 days supports a nuanced framework based on use case and tolerance for adaptation. Students doing general academic work, web browsing, document writing, spreadsheet work, email, video calls, will find Linux Mint fully capable of supporting their workflow on older hardware. The performance improvement on constrained hardware is genuine and significant. LibreOffice handles most academic document formats adequately, and the free open-source software model eliminates software costs that represent meaningful expenses for students. The caveat is institutional software. Universities increasingly use web-based platforms, but some institutions require specific Windows-only applications for exams, labs, or course-specific software that may not have a Linux equivalent. Office users in environments standardized on Microsoft 365 face a more complex evaluation. The web-based versions of Microsoft Office applications, Word Online, Excel Online, PowerPoint Online, function on Linux through a browser, preserving document format compatibility with colleagues using native Office applications. But the experience of browser-based Office is not equivalent to native Office on a feature-for-feature basis, and users who rely on advanced Word or Excel functionality may encounter limitations. For Office environments where document compatibility and collaboration workflows are tightly defined, the risk of friction from Linux adoption needs to be weighed carefully against the performance benefits. Developers, software engineers, data scientists, web developers are among the users for whom Linux Mint is most naturally suited. The Linux command line environment, the package management system, the native availability of development tools including Git, Python, Node.js, and the full GNU toolchain, and the close relationship between the Linux desktop environment and the Linux server environment that most applications are ultimately deployed to all represent genuine advantages for development workflows. Developers who spend significant time in the terminal rather than in graphical applications will find the transition to Linux Mint less disruptive than users whose workflow is primarily GUI-driven. Content creators face the most difficult recommendation because the professional creative software ecosystem remains firmly anchored in proprietary applications that are not available on Linux. Photographers who rely on Adobe Lightroom or Capture One, video editors who use Adobe Premiere or DaVinci Resolve. DaVinci Resolve does have a Linux version, notably, and graphic designers whose work requires Adobe Illustrator or InDesign will find Linux Mint an incomplete solution for their professional needs. The open source alternatives, GIMP for image editing, Kdenlive or Shotcut for video editing, Inkscape for vector graphics, are capable tools with active development communities, but they are not drop-in replacements in professional environments where client deliverables and industry workflows define the software requirement. Owners of older laptops who are experiencing the specific problem this experiment addressed, a machine that meets Windows 11's minimum hardware requirements but feels sluggish and unresponsive under Windows 11's resource overhead, represent the group for whom Linux Mint's value proposition is clearest and most immediate. The performance data from this experiment supports the conclusion that this category of hardware benefits genuinely from the transition, and that the improvement in daily usability is substantive rather than marginal. 30 days of benchmark data, daily use observations, compatibility discoveries, and workflow adaptations produce a conclusion that is more interesting than either Linux advocacy or Windows loyalty would prefer it to be. Linux Mint on this aging laptop is genuinely measurably faster than Windows 11 on the same hardware. The boot time difference, the RAM efficiency, the application responsiveness, the battery life improvement, these are not placebo effects or subjective impressions. They are reproducible measurements that reflect the operating system overhead that Windows 11 imposes on hardware that was not designed with that overhead in mind. But raw performance is not the only measure of a computing experience worth having. The software ecosystem, the peripheral compatibility, the institutional and professional application requirements, the learning curve of rebuilding workflow familiarity in a new environment, these factors shape the daily experience as significantly as the benchmark scores. A faster operating system that cannot run the applications a user depends on is not a solution. It is an exchange of one problem for a different one. What 30 days revealed, beyond the numbers, is that the question of whether to switch to Linux Mint is not fundamentally a question about operating systems. It is a question about workflow. What software do you actually need? How deeply are you embedded in ecosystems that assume Windows? How much adaptation are you willing to invest in exchange for meaningful performance gains on hardware that deserves more years of useful life than Windows 11's trajectory may allow? For the specific hardware tested here, and for the millions of similar machines carrying similar specifications that are currently struggling under Windows 11's weight, Linux Mint offers something that no amount of Windows optimization, registry tweaking, or startup program disabling can provide: an operating system that was built with efficiency as a design priority rather than as an afterthought. And perhaps the most honest reflection that 30 days of real-world use produces is this: the laptop did not feel old on Linux Mint. It felt capable again, which raises the question that every owner of aging hardware eventually confronts, not whether their machine has reached the end of its life, but whether the software running on it has simply outgrown it. Because hardware does not become obsolete on any fixed schedule. It becomes obsolete when the software it runs decides it has